You know, we spend so much of our time writing code, just thinking about it line by line. But have you ever kind of zoomed out and wondered about the hidden map that our programs are actually creating? Well, today we're going to trace those pathways and really see how our code comes to life.
I mean, really think about that for a second. When you sit down and write a program, you see text, right? You see functions, you see variables, but what does the machine see? What kind of structure is it following to get from point A to point B?
Because, it's not just seeing a simple list of instructions to read from top to bottom. It's actually seeing a whole network of pathways. It sees these moments where it has to make a choice, and other times where it has to circle all the way back and do something again. And this network, this whole structure, that's what we call control flow.
So, okay, why even bother looking at our code this way? Well, it turns out this hidden map isn't just some cool abstract idea. It's actually fundamental to how our software even works. Let's dig into why it matters so much.
This map, it's probably the single most important tool a compiler has to make sense of your program. It's the reason your code can be made to run faster. It's why a debugger can tell you exactly how you ended up in some impossible state. And let's be honest, it's how we can untangle that spaghetti code that we all end up writing sometimes.
Thinking like this is really a shift in perspective. Instead of just seeing the individual lines of code, the bricks, we're starting to see the logical structure they're all building together. And today, we're going to build up that perspective, just one simple idea at a time.
All right, so let's start piecing together our map. Every journey starts with a single step, and on our code's map, the absolute simplest path you can take is just a straight road.
So take a look at this little piece of code here. See that sequence of assignments? There are no decisions being made, no jumps. The computer just starts at the top of that section and runs each line, one after another, no questions asked. These are the straight roads on our map.
And this super simple idea is so important that it actually has a formal name, a basic block. It's just a chunk of code with one way in and one way out. Once you enter a basic block, you're guaranteed to execute every single instruction inside of it until you pop out the other end. It's really the fundamental unit of our control flow map.
And finding these things isn't some kind of magic. As you can see, there's a really simple, repeatable process for it. You pretty much just scan through the code and slice it up anytime the path could possibly change, like when you hit a jump or a conditional branch.
Okay, so we've got our straight roads. But, a map with only straight roads isn't going to get you very far, right? To make it useful, we need crossroads, we need intersections. Let's take a look at how those are formed.
An if-else statement. Now, that is a perfect example of a crossroad in your code. Depending on some condition, the program's execution is going to follow one path or it's going to follow a completely different one. It's a fork in the road. And honestly, these decisions are what give our programs all of their power and flexibility.
So these lines that connect our basic blocks are straight roads. They're called edges. And when you put the blocks, which are the nodes, together with the edges, which are the paths, you get what's known as a control flow graph. And there you have it. That's the complete map of your program's logic.
Okay, so we have straight roads and we have crossroads. That covers a whole lot of ground. But what about the last major feature of pretty much any roadmap, the roundabout? What happens when our code needs to circle back on itself?
Well, loops, like a while loop or a for loop, they are the roundabouts on our map. They create a path that lets the computer jump from a point further down in the code all the way back to an earlier point. And this lets it execute a block of instructions over and over and over again.
And this perfectly illustrates the idea of what's called a back edge. In our flow graph, a back edge is just an edge that points backwards in the code. Seriously, anytime you see a back edge, you can be sure you found a loop. It's the technical signature of repetition on the program's map.
So, we've defined our map, we have our straight roads, our crossroads, and our roundabouts. Now, let's put it all together and see why thinking about our code this way is so incredibly powerful. Let's just look at this piece of code. As plain text, wow, it can be really tough to follow all the possible paths, right? You've got nested loops, if statements. It's kind of just a wall of text.
But now, using what we've learned, we can start to see the actual structure hiding in there. We can spot the basic blocks, those uninterruptible sequences of instructions. See? The code isn't just a list anymore. It's becoming a set of distinct logical chunks.
And finally, we connect those blocks with edges that show all the jumps and the branches and the loops. And there it is. The hidden map, the control flow graph, is finally revealed. Every possible journey that this program could ever take is now visible as a path through this graph. It's pretty cool.
And this map is the whole reason a compiler can give you that warning about, say, unreachable code after a return statement, or why it could take a loop that looks slow and somehow magically make it faster. It's not magic at all. The compiler's just reading the map to find shortcuts and dead ends.
So here's a really simple takeaway. You don't need to go around drawing these graphs by hand, of course, but you can definitely carry the idea of the map with you.
The next time you write a bit of logic, just for a second, picture the little map you're building. Are you making a straight road? Are you putting in a fork, a roundabout? Just having that simple mental model can make your own reasoning about your code so much clearer. What this all really shows us is that code isn't just a sequential script. It's a dynamic, living landscape with its own unique geography. By learning to see this hidden map, you really move beyond just being a writer of code. You start to become an architect of logic, designing the very pathways that bring your programs to life. I hope this gives you a new way to see your own work. Thanks for joining me.